Okay, you guys, I am going to do lesson 13.3, part 3, and you have this piece of paper in your original 13.3 notes. It is called All Students Take Calculus. And if you're like, what in the world, what does that even mean? All Students Take Calculus is a mnemonic to show what positive or negative ratios are in each quadrant. And if you're still like, what are you talking about? Well, I'm so glad you asked, because I have made this cute little piece of paper right here for you. And the lesson that I'm about to teach you is going to involve All Students Take Calculus, and I'm going to use this everywhere on my paper. And I'm trying to explain to you what this means. If you were to be some angle right here in the first quadrant, drop a perpendicular and create a cute little reference triangle. And I'm using 3, 4, 5 in every one of these examples just so it makes the numbers real small and easy. Then clearly sine would be 4 over 5, cosine 3 over 5, tangent 4 over 3. But because this on the x-axis is going right and this on the y-axis is going up, these numbers are positive. All three ratios for sine, cosine, and tangent create positive ratios for any angle that you would try to evaluate in the first quadrant. Now, cosecant, secant, and cotangent are going to do the exact same thing that their reciprocal functions do. So I wrote down cosecant, secant, and cotangent just in quadrant 1, just to let you know that the reciprocal function follows what it does for each one of these quadrants, although I didn't write these 3 down in every other example that I did. All right, so let me do this again. If you have an angle in quadrant 2 and you use the angle next to the x-axis and the terminal side of your angle as your reference angle, and you were to go evaluate for sine, cosine, and tangent of angle theta prime, you're going to wind up with a 4 over 5, a negative 3 over 5, and a negative 4 over 3. So what this is telling you, students, sine's ratio is the only one that's positive if you evaluate trig functions for angles in the second quadrant. Sine's ratio is the only one who's positive. The other 2 are negative. Okay? Then, if you are an angle in quadrant 3, you find your reference angle, you drop your perpendicular, you have sides of your reference triangle. If you were to evaluate sine, cosine, and tangent, you would get negative 4 over 5 for sine, negative 3 over 5 for cosine, and 4 over 3 for tangent. What this is meaning in the third quadrant, tangent is the only guy who has a positive ratio for an angle in the third quadrant. And you can clearly see sine had a negative ratio, cosine had a negative ratio, tangent is the only guy who has a positive ratio. If you are an angle in quadrant 4, and you have a reference angle, you drop your perpendicular, you make a reference triangle, you have the sides of your triangle. Sine is negative 4 over 5, cosine is adjacent over hypotenuse, it's 3 over 5, tangent is opposite over adjacent, I messed that up. It's opposite over adjacent. This number right here should be a 3, muffins. I messed that up on your paper, okay? Maybe I'll go fix it before I actually put it up on your Google Classroom. Anyway, at that point, what I'm trying to get you to see is cosine. His ratio is the only one that's positive for any angle in the fourth quadrant. So that is what all students take calculus means. All trig ratios for sine, cosine, and tangent will be positive if you're an angle in the first quadrant. Sine, he's the only guy that's going to have a positive ratio for an angle in the second quadrant. Tangent, he's the only guy that's positive in the third quadrant. And cosine, he's the guy that has a positive ratio in the fourth quadrant. So let me do some homework or some notes with you actually before I even worry about the homework, okay? This says, let the point 5, negative 12 be a point on the terminal side of theta. Well, if you went 5, negative 12, you wind up at this point right here, okay? So we're really talking about this angle right here. This is your reference angle. If you drop a perpendicular, there's your reference triangle. This side has a length of 5, this side has a length of 12, and if you want to say, no, it has a length of negative 12, I totally get it, but I'm leaving out the signs of the triangle on purpose because I'm going to show you how I'm going to take care of that. You could then go do Pythagorean's theorem to go find out your hypotenuse. If you square root both sides, you're going to find out that the hypotenuse has a length of 13, okay? So sine would be opposite over hypotenuse. Cosine would be adjacent over hypotenuse. And tangent is opposite over adjacent. But now what I'm going to do is all students take calculus. I know cosine is the only guy who should be positive, therefore the other two guys are negative. So that's kind of the way this all students take calculus mnemonic kind of helps you understand how to do your ratios if you didn't draw your reference triangle as being a negative 12, okay? These problems, you don't actually have a reference triangle. These are going to look at whether or not the acute angle in the problem is the appropriate reference angle for this one, and then whether or not these would be positive or negative ratios. And I don't know how much room I have, so I'm going to work number 2 right here. And where is a 200 degree angle? A 200 degree angle would be over here. And if this is 180 and this is 200, then yes, your reference angle would be 20 degrees. So that is the appropriate reference angle for the sine of 200. However, all students take calculus. Tangents ratio is the only guy that would be positive in the third quadrant. So this thing would have a negative value. But if you were to do the sine of 20 degrees, he's right here. This guy, because he's in quadrant 1 and all ratios are positive, he would be a positive. So if you hit sine 200 on your calculator and you hit sine 20 on your calculator, the decimals will be the exact same number, but this one's going to be positive and this one's going to be negative, and those are not the same. So the answer to this one is that this is false. It is not a true statement, okay? Now, let's look at number 3. I want to find the cosine of 140 degrees. Well, the cosine of 140 degrees would be over here in the second quadrant. There's 140, here's 180. So yes, there would be another 40 degree reference angle. So this is the appropriate reference angle. And then if you say all students, sine is positive. That's how I know cosine would be negative. And if you do the cosine of 40 degrees is again in the first quadrant, cosine is positive here. But this particular problem there's a negative in front of it. So it'd be negative of whatever that ratio was. So a negative and a negative, that would therefore make this true. Okay, so the answer to number 3 would be true. And then if you looked at problem number 4, where is a 300 degree angle? Well, 300 degree angle is over here. And this is 360. So you are 60 degrees shy of being a full circle. That is the appropriate reference angle. But all students take calculus. Cosine is the only guy who has a positive ratio in the fourth quadrant. So this guy has a negative ratio. But if you were talking about a 60 degree angle, you're in quadrant 1 and all of these guys are positive. Again, if you were to hit tangent 300 on your calculator and tangent 60 on your calculator, the decimal answers would be the exact same, except this one's going to be negative and this guy's going to be positive, and therefore they are not equal. So the answer to this one is false. Okay? And then I'm going to ask you to evaluate without a calculator. And I'm going to go draw a 150-degree angle. I know this is 180, so in this particular problem, there's a reference angle of 30 degrees. If I drop a perpendicular and create a reference triangle, this gives me a 30, 60, 90 degree triangle, which I know is 1, 2, square root of 3. So if I want cosine, I know I'm talking about SOHCAHTOA, so it's going to be adjacent over hypotenuse. However, all students, sine is positive. That's why I know my final answer has to be negative square root of 3 over 2. Okay? Let's take a look at the cotangent of 225 degrees. 225 degrees is over here in quadrant 3. You just crossed 180, so 225 minus 180 would leave you a reference angle of 45 degrees. If I drop a perpendicular and create a reference triangle, what I really have is a 45, 45, 90, which would be 1, 1, square root of 2. And clearly, as you can see, I've not tried to label these -1 and -1. I'm just going to go address the problem. If tangent, TOA, is opposite over adjacent, then I need adjacent over opposite. Adjacent over opposite. So the adjacent side is 1, the opposite side is 1. But then when I go do all students take, I know tangent should be positive. In this particular problem, I'm doing cotangent, but cotangent should be positive because its reciprocal tangent is positive. So that's why my final answer is a positive 1 for that. Okay? Now, let me do the cosecant of 300 degrees. A 300-degree angle is over here in the 4th quadrant. And this is 360. So I know I'm talking about a 60-degree reference angle. If you drop a perpendicular, you get a cute little blue reference triangle that you know is a 60, 30, 90-degree triangle. So it's going to be 1, 2, square root of 3. Those are the lengths of that. Cosecant is the reciprocal to sine, and sine is opposite over hypotenuse. So cosecant would be the hypotenuse over the opposite. So your hypotenuse is 2, your opposite is square root of 3, and you would rationalize your denominator. So you would get 2 on the square root of 3 over 3. However, all students take calculus. Cosine should be positive. Therefore, cosecant, which is the reciprocal of sine, should be a negative. So your final answer is -2 on the square root of 3 over 3. The sign matters whether or not you get this problem correct or not. It depends on whether or not it's going to have a positive or negative ratio. So that's why all students take calculus is so helpful. Cosine is the only guy who should be positive. But this is the ratio that's the reciprocal to sine, and he would be negative. That's why cosecant is also negative. So there's kind of some examples there. And then the last page that I would like to show you is kind of the last page of notes here. It talks about find the 5 other trig functions in these scenarios. These may be just seem a little bit weird, but that's why I want to go over them, okay? It says if the cosine of theta equals negative 2 over 5, and theta has to be between 180 and 360. This is where you are going to start. This kind of gives you a location of where you could be. If you are between 180 and 360, then you are either in quadrant 3 or quadrant 4, okay? So this just kind of narrows down your quadrant. It's either in quadrant 3 or quadrant 4. And the second part of this problem says, okay, cosine has a negative ratio. So if you look at all students take calculus, in which one of these two quadrants that you've identified yourself, where is cosine going to give you a negative ratio? Well, it's going to give you a positive ratio where the C is. So that's how I know that the quadrant that I am in has to be a third quadrant angle. So once you know that you are in a third quadrant, go draw an angle over in quadrant 3. So there you are, you're an angle in quadrant 3. This is your reference angle. If you drop a perpendicular and create a reference triangle, you know that cosine means adjacent over hypotenuse. So your adjacent side is 2 and your hypotenuse is 5. And if you're like, well, why didn't you make this negative 2? I certainly could. But again, I'm not going to worry about labeling my triangles as being positive or negative. I'm going to take care of the signs at the end. And you would go do Pythagorean's theorem to figure out that this side had a length of the square root of 21. Notice I didn't do that for you because I'm tired of talking on this long video. So sine would be opposite over hypotenuse. That would be the square root of 21 over 5. Cosine, we already knew, was negative 2 over 5. Tangent is opposite over adjacent. And then your reciprocals would just flip. Okay, but here we go. This is kind of what I want you to see. All students take calculus. Tangent is the only guy that should be positive. So tangent and his reciprocal, cotangent are positive. We already knew cosine was negative. That's how I knew secant was negative. But sine and cosecant should also be negative. So that's how it lets me know whether or not my ratio should be positive or negative. I'm talking about an angle in third quadrant, and there's kind of a problem with everything all in one. Okay? In problems 9 and 10, I didn't ask you to go find all of the other trig functions. I just picked one just to make it easier. But this is a two-part problem. And I kind of recommend starting here first. And it says, in this problem, theta has to be between 0 and 270 degrees. Well, if you go draw a little diagram, here's 0, 270 degrees is all the way over here. So in this problem, I'm talking about either a quadrant 1 angle, a quadrant 2 angle, or an angle in quadrant 3. Well, of these three, how do I know? Well, the second part of this is cosine has a positive ratio. So if you have all students take, the only place where cosine is positive is right here. So the quadrant that you're in is quadrant 1. So if you were to go draw a first quadrant angle and drop a perpendicular, here's your angle. Cosine again means adjacent over hypotenuse. You have to know what it means. So it's 2 and it's 3. If you do Pythagorean's theorem, you would find out that this length is the square root of 5, okay? So I want the cotangent. TOA. Tangent is opposite over adjacent, so cotangent would be adjacent over opposite. So the adjacent side is 2. The opposite side is the square root of 5. And then we know it's positive because we're in the first quadrant, and that's gonna be 2 on the square root of 5 over 5. That's the final answer. And it should have a positive ratio because all trig functions have a positive ratio. So this answer is 2 on the square root of 5 over 5, in case you couldn't read that. And the big thing here is you're trying to identify what quadrant you're in, okay? And to be honest, you could have said the cosine of the angle has a positive ratio. So where are you? You're either in quadrant 1 or quadrant 4. But then it says, okay, well, you have to be between 0 and 270. Well, the only one between 0 and 270 is this one. So that could be another way to look at this problem. We could have done the same thing here. Where is cosine negative? Well, cosine is negative here and here. But of those two places, you have to be between 180 and 360. Well, 180 is here and 360 is here. So it has to be this guy right here. So that might be another way to identify what quadrant you're in. And we may try that over here in this last example. All right, so here we go. It says the tangent of your angle has a negative ratio. Well, all students take calculus. Where is tangent negative? Tangent is negative in quadrant 2 or quadrant 4. But in this particular problem, it says the cosine of the angle is less than 0. If you're less than 0, that means you are negative. And of these two places that you just identified from this step, in which one of these quadrants does cosine have a negative ratio? Well, here, because the C is written here, which means cosine is positive here. So that's how I know I'm talking about an angle in the second quadrant. So go draw an angle in the second quadrant. Here is your reference angle. Drop your perpendicular as your reference triangle. Tangent means opposite over adjacent. So the opposite side is 3 and the adjacent side is 4. Again, you might be like, hey, why didn't you do negative 3 or 4? I could have, but I'm going to go do the sine, and I know this side is 5. Sine is opposite over hypotenuse. But because all students, sine I know is positive for an angle in the second quadrant. So the answer to this one is 3/5. So maybe this is semi an explanation for 13.3 part 3.